In this video, we are going to review factoring quadratics for any trinomial, and in fact, we're also going to look at one of our special cases, difference of squares. So remember, for any trinomial in the form ax squared plus bx plus c, you can factor first by multiplying a times c, and then looking for factors of ac that add to b. Think about your signs. You're going to fill your terms into the box, pull the GCF out of each row and each column, and then do a quick multiply to check. So we have two examples here, but I'm going to move forward to our examples that we're going to work together. Number one is actually asking us to multiply, so I don't need to do all of that. I know I need to multiply here because of the way the question is written. When we multiply, we take a pair of binomials, two binomials, multiply them together and get a trinomial for our answer. When we factor, we're going backwards. We start with the trinomial, we're looking to write it as a product. I wanted to start with multiplication so we could see how the two are linked. So with multiplication, I put my 5x minus 2, 5x minus 8 on the outside, and then to get each box, I multiply that row, that column. Then if you prefer using the FOIL method or the distributive method, you are more than welcome to do that. I'm going to use the box method to factor though. Combining my like terms, I get 25x squared. These both are negative, so signs are the same. Add and keep the sign, and then plus 16. So again, when we're multiplying, we start with two binomials and we end with a trinomial. Okay, now we're going to be factoring. So to factor, it's in the form ax squared plus bx plus c, so I'm going to start by multiplying a times c. Here my a is 1. And then I want to find factors of ac that add to b. That's when I'm going to do my little chart. So I want to find two things that multiply to 40. That's what being a factor means. And add to b, which in this case is negative 13. Now I can already see what my choices are going to be there, but I am going to go ahead and list them out. 2 times 23 doesn't go. 4 times 10. 5 times 8. 6 doesn't go. 7 doesn't go. And then we'd start repeating. So 5 and 8 are the two that I'm going to do. Now I should think about my signs. I'm multiplying to a positive, so my signs are the same. Since I'm adding to a negative, they're both going to be negative. So negative 5 and negative 8 multiply to 40 and add to negative 13. Now my next step is to fill in the box. So remember what we're going to do is in the box, we're going to put first term here, last term here. So this time I have the inside of the box. I'm trying to find the outside. Remember, I'm going to rewrite my middle two as negative 5k. Don't forget the k, it's important. And negative 8k. So what I have inside the box here is equivalent to my trinomial. It's equal. Then I look inside each row, each column. So I'm going to start by looking here. I'm going to go to the first row and look for what's common, and that's just a k. Then I'm going to go here. What do they have in common? And that is also just a k. Then I am going to go here, and they have an 8 in common. And because this is negative, this is going to be negative. And then last, I go here, and they have a 5 in common. And because this is negative, this is going to be negative. Always multiply to check, especially because of the signs, the positives and the negatives. K times k is k squared. K times negative 5 is negative 5k. K times negative 8 is negative 8k. Negative 8 times negative 5 is a positive 40. So my answer here, k minus 5, k minus 8. Let's go to example 3. So again, I'm going to multiply a times c. So 3 times negative 5 is negative 15. I'm going to look to multiply to negative 15 and add to negative 2. So 1 and 15, 2 doesn't go, 3 and 5, 4 doesn't go, 5 we'd start repeating. Thinking about my signs, because I'm multiplying to a negative, my signs are going to be different. Because I'm adding to a negative, my larger one's going to be negative. So I'm going to use 3 and negative 5. Filling in my chart, my table, and then pulling out what's common. So with my 3p, my first row, 3p squared and 3p, that has a 3p in common. My first column just has p. My second row has negative 5. 3p and 5 don't have anything in common, so that's a 1. 1 is always common. Do a quick multiply to check. 3p times p squared is 3p times p is 3p squared. 3p times 1 is 3p. P times negative 5 is negative 5p. Negative 5 times 1 is negative 5. So my answer, and it doesn't matter what order you write it in. If you wrote 3p minus 5 times p plus 1, that's fine. Okay, last one. Notice with this one, my b is 0. I don't have a middle term. And I know it's the middle term that's missing because I don't have the x to the first. I have the x squared, I have the constant. So this is my a, this is my c. So when I multiply a times c, I get negative 9. And I'm trying to add to 0. When that happens, it's almost always going to be a perfect square. And I'm going to do one positive, one negative. Because 3 plus negative 3 is 0. So I didn't even try the other ones. So I'm still going to do first and last. And then my middle terms. Pulling out what's common. 3x, 3x, just the 1, and then negative 1. Of course, multiply to check. But I knew what this one's going to look like because it's that difference of squares. This one has the 2 terms, both perfect squares, subtraction in the middle. So I knew it was going to be 2 binomials that were exactly the same except the sign in the middle. So I didn't check.